Alright, after dealing with relations in the last section, we're now ready to talk about something called a function. And a function is a very special type of relation. So let's remind ourselves of what a relation is. A relation is a set of ordered pairs. Okay, that's the definite need right there. We've got to have a set of ordered pairs. Could be dealing with words or people or colors, as we saw yesterday. And it can be expressed as a mapping, a table, or if we've got numbers, then it can be expressed as a graph. Okay, so let's write the word graph there. Now, for our purposes, there are lots of different definitions of functions, but for our purposes, we're going to say that a function is a very consistent mathematical rule that creates this set of ordered pairs. So here's what the function does. The function takes the first number, usually the x. We're going to start off by giving the function an x, and it performs some math on it, whatever that math happens to be, and then it gives you an answer. So if we usually plug in an x, or start with an x as the first number, then what we get out is usually the y. Okay? Now, because a function is so consistent, because it does the same thing every single time, each x can correspond with only one y. Okay, it can only correspond with one y. So put simply, and this might be something that you want to memorize as far as the definition goes, a function is a set of ordered pairs where each x can be matched up with only one y. So a function is a set of ordered pairs where each x can be matched up or relate with only one y. Now, it's important to be able to tell when a relation is just a plain old relation and when it is consistent enough, or when it meets this definition of what a function is. And that's what we're going to be doing a lot of in this particular section. So I'm going to slide this down, and we're going to keep that definition right there in mind. So each x can correspond with or match up with only one y. So it says determine whether each of the following relations is also a function by making a map and a graph. So let's take a look here. We've got the set of ordered pairs. Let's go ahead and make a map here. So we've got -5, and we've got -1 and 0 and 2 and 4. Okay, we don't have any repeats there. And then we've got a 2, we've got a 4, we've got a 1 in both of these, and then we've got another 4 right here. So I'm not going to write that other 4 there. Let's just draw this mapping here. So -5 corresponds to 2, -1 corresponds to 4, 0 corresponds to 1, and then 2 corresponds to 1, and then 4 corresponds to 4. Okay? So we've got this mapping done right here, and now we're going to draw the graph for this. So we're going to do -5, 2, so we're going to go back 5, and we're going to go up 2 from the origin. -1, 4, back 1 and up 4, so we'll be right there. 0, 1, remember if the x-coordinate is 0, we're right on the y-axis. 2, 1, so over 2 and up 1. And then we've got 4, 4, so 4, 4, so we would be right there. Okay? All right, so let's think about this definition of a function. It's a set of ordered pairs. We definitely have a set of ordered pairs. And then we just need to check this. Does each x match up with only one y? Does each x correspond, map onto only one y? Well, let's take a look here. 5 only corresponds to 2, -1 corresponds to 4, 0 corresponds to 1, 2 corresponds to 1, and 4 corresponds to 4. Now, each one of these, you'll notice, corresponds to only one of the y's over here. So each of these x's corresponds to only one of the y's. Now, some people look at this and they say, well, wait a minute. This 0 and the 2 both correspond to 1, but it's important to keep in mind the definition. Each of the x corresponds with only one y. It's only matched up with one y. It doesn't say the other way, like each y can correspond with only one x. Okay, that's something that's a little bit more particular. So on this one, each x does correspond with only one y. We've got the -1 and the 4 also corresponding with 4, but it's totally okay because you'll notice that there's only one line going out of each one of these. We're only mapping each one of these to one of them over here. So this one is a function, okay? So we're going to write, yes, this is a function. Yes, that is a function, okay? Because each x corresponds to only one y. Now, I'm going to change colors here, and this is example 1 star. Here's what we're going to do. We're going to add one more point to this. We're going to add the point 2, 4. So 2's already in there, 4's already in there, and then we're going to need to draw this line right there to represent that. So we've got 3 of these x's corresponding to 1 of these y's, but that's not the problem. Here's the problem. If I were to write this point up here, so the next point here would be 2 comma 4, here's the problem. 2 corresponds to 1 and 2 also corresponds to 4. So you can kind of see that here. You can really see it on this one because you can see that 2 goes to 1, it maps onto 1, and it maps onto 4. So that x, the 2, can be matched up with 2 different ones. 2 matches up with 4 and 2 matches up with 1, and that's not okay. We can also see that if we graph this, so if I were to graph the point 2 comma 4, I go over 2 and I go up 4, and what we notice is this blue point, the one that we added, is right on top of this old point. So you'll notice all the red points, none of them are stacked on top of each other. None of them have the same x coordinate. But the minute they have the same x coordinate and a different y coordinate, they're going to be right on top of each other. So that's the problem. That is not okay. So the answer on this one is no, this is not a function. It's not a function because 2 corresponds to 2 different x values, or sorry, 2 different y values. It corresponds to 4 and it corresponds to 1. I'm going to write that this way, okay, just so we can highlight it. And these 2 are right on top of each other. They have the same x value, but on this one we only go up 1, and on this one we go up 4. So they're stacked right on top of each other. Okay, let's take a look at this next one here. It says, determine whether the following relation is also a function by making a mapping and a graph. So we're going to do the same thing again. So we've got, let's write them down, -4, -1, 0, 2, 4. Okay, and then we've got a 2. That one's also a 2. That one's a 2. That one's a 2. That one's a 2, okay, something going on here, and then we've got a 5. Okay, so let's go ahead and map these. -4, 2, -1, 2 goes to the same one, 0, 2 goes to the same one, 2, 2 goes to the same one, 4, 2 goes to the same one, and then 4, 5. So you'll notice that we've got a problem right here. We know this is not going to be a function because the 4 already corresponded to 2. It already matched up with a 2, and this says that it also matches up with a 5. So let's go ahead and graph this set of ordered pairs. So -4, 2, -1, 2, 0, 2, 2, 2, 4, 2. Okay, now if we left it like that, you'll notice that none of these points are stacked on top of each other, so we're totally okay there. But here's where the problem comes in. The problem comes in when we start graphing this one. 4, 5. That one is right on top there. So the answer to this one is no, this is not a function. This is not a function, and the problem is right here. Those are stacked on top of each other, and again the problem is right here because the 4 corresponds to 2 different y values, and that's not okay. Now there's a good reason why each x can correspond with only one y, and we can look at these and we can tell visually how to tell whether or not we've got a function, and it deals with the graph. Okay, so if I come over here and we take a look at where the problem areas were, the problem area is right here. The problem area is these 2 points right here. They are stacked right on top of each other. Right on top of each other. There's no problem with any of the other points, but there's a problem when we stack these right on top of each other. And you'll notice what they do is they make a vertical line. So they're stacked on top of each other in a vertical line. Okay, so keep that in mind. Next one says, suppose a function took the number of hours you worked and told you your pay in return. Would this be a function? So let's run through here. We've got a set of ordered pairs. Let's see if we can figure out what the pattern is here. So again, this is going to be the hours you work, and this is going to be the pay that you get. So if you work 0 hours, then you get $0. If you work 1 hour, you get $10. If you work 2 hours, you get $20. So let's go ahead and fill this in. So this would be $30 for 3 hours work. If we work 4 hours, we'd get $40, and 5 hours, we'd get $50. Okay, so we'll go ahead and match these up. This is going to be a 0, a 1, a 2, a 3, a 4, and a 5. And we've got 0, 10, 20, 30, 40, and 50. And again, just like you would expect, these match up just perfectly, right across from each other. We don't have any of these issues where we've got one of these x's or one of these hours corresponding to different pays. And let's see, we're going to do this as 50, and this would be 10, 20, 30, and 40. We'll go ahead and graph this. We'll label everything. This is hours, and this is the pay we get. So 0, 0, 110, 220, 330, 440, and 550. And you might recognize that this is a proportional relationship. These are directly proportional. So we can draw a line that connects these, so it would look something like that. And you'll notice that the points that we've got on here, gosh, that's just a nice perfect line. We're all set to go. So if we look at this and we say, well, gosh, are any of these points stacked on top of each other? They're not. This is a nice consistent rule. When I go in and work, I get the same hourly rate, if you want to think of it that way. And then we're going to take a point here, and it says, as an employee, would we like it if we added the point 5, 10? So 5, 10 would look like this. On the map, it would go like that. And on the graph, it would go right here. Now you'll notice that these are stacked right on top of each other, and think about why we like functions in real life. So here's what this would say. If we go in and work, most of the time we get $10, but if you happen to work 5 hours, say your boss throws this one in there, sometimes when you work 5 hours you get $50, and then other times when you work you get $10. We wouldn't like that at all. We don't like this inconsistency right here. We want to know that if we go in and work for 5 hours, we're going to get the $50. We're not going to get the $10, okay? So this is a problem, okay? And again, you'll notice that they're stacked right on top of each other, and we don't like that. We like to know that when we put in an X, we get exactly the same Y out every single time. It's that consistency that we're after here. So this one is not a function if we added that one. Before that, then it was a function. So up here, this was a function. Let me slide that over so it looks like it's in a little bit better place. So this one would be a function. So it's a function if we just kept the red stuff. It's not a function if we kept the blue stuff. And again, there's a good reason why we don't like that inconsistency. So we're going to flip the page over, and let's talk about a visual test that we can use to tell whether or not a function or a relation is a function. So we can easily tell if a graph comes from a function because none of the points will be stacked on top of each other like we were talking about previously. In other words, the graph will pass what we call the vertical. So write the word vertical, and it's C-A-L at the end of that, vertical, not C-L-E. So vertical line test. So here's the vertical line test. This is the vertical line test for functions. Any vertical line that we draw on the graph will intersect the graph of the function only once. It will only cross the function once when we draw that. So on example 4, it says, which of the following graphs are functions? So if we take a look at each one of these, I'm going to draw some vertical lines here. So this one doesn't cross it at all, but I start crossing it once, cross it once. I just draw a whole bunch of vertical lines, and we see if there are any that are stacked on top of each other. So this one is a function. Okay, let's take a look at this next one. Doesn't cross it at all. If I do it right here, it just crosses it once right there. But the minute I go over here, it crosses right there and it crosses right there. So this one is not a function. So the vertical line test is really cool. We don't have to do any mappings. We don't have to think about the ordered pairs or anything like that. All we have to do is look at it and say, gosh, can I draw a vertical line that touches the graph more than once? And on this one right here, every one of those lines crosses it just once, so that one is definitely a function. Okay, so visually it's really easy to tell. If we've got a set of ordered pairs, then we have to be a little bit careful. So we go through here. If you wanted to draw a mapping and see if any of the x's correspond to more than one y, then you could do that. But there's a pretty easy way to tell. Let's just go through here and see if there are any repeats of the x, because that's the only time we're going to have a problem is if we've got a repeated x. So if you come up here, you'll notice that we didn't have any problems until we put another one that had a 5 in it. We didn't have any problems up here until we got to the very end where we had a repeated x. And we didn't have any problems here until we put the one where we had another 2 on that one. So let's run through here and let's take a look. We've got a 1, a 2, a 3, a 4, and a 5. This one is definitely a function. It doesn't matter that those 2 are 7s. It doesn't matter that those 2 are 8s. This one is a function. Okay? If we come over here, let's take a look at this one. We've got 2 1s. Now, if this had been a positive one, if we just kind of repeated the entire point again, then that would be okay. But here's the problem. This one corresponds to 1, and it corresponds to -1. So this is not a function. Let's see if there are any other problems. 4 corresponds to 2 and -2. 9 corresponds to 3 and -3. So there's a problem with this pair, and this pair. Every one of those is a problem right there. Okay, because we've got a repeated x value and we've got a different y that it corresponds to. Okay, determine whether the graphed relation is a function. Again, this is the easiest. When we just go through and we look at it and we say, gosh, vertical lines only touch this once, so this one is a function because it passes the vertical line test. So I'm just going to say passes vertical line test. And this other one, immediately we just draw one of those, it fails the vertical line test. So we'll say not a function, and we're going to say fails vertical line test. Okay? All right, so a couple of thought questions. What is a mathematical function? You kind of need to be able to rattle off this idea. So it is a set of ordered pairs, and it matches, and we're going to use x's and y's a lot, so matches each x to only one y. Okay, that's what we're going to say is a function. And how can you tell if a graph is a function? We're going to say that it passes the vertical line test. That's going to check and make sure that each x corresponds to only one y. And then we've got some true-false questions here. It says, true or false, all functions are relations. Well, let's stop and think about that for just a second. A function is a set of ordered pairs where each x corresponds to only one y. Okay, it matches up with only one y. A relation is just a set of ordered pairs. There's no other special condition on that. So all functions are relations. That is true. Then it says all relations are functions. Okay, now functions have this extra condition on them that each x can match up with only one y. A relation is just a set of ordered pairs, no special conditions. So just because you have a relation does not mean that you necessarily have a function. So that one's going to be false right there. Okay, these problems are similar to what are on your assignment. Really important that we be able to tell the difference between a relation and that extra special condition that makes it a function, because we're going to be dealing with functions almost all the time in the math classes that you take. So good luck.